Morning, Mr. K.
Yeah, good morning, Eric.
Mm. Today we talk about something related to physics, which I think is very important. And so have you, yeah, why I will come out this topic? Because recently I try to teach myself the physics. In other words, I try to learn physics. And I came across this, for example, the gravitations, the gravity, and also like the electromagnetisms, and also we also got like the nuclear, we also got like the energy. So all of these things I think is very important in physics. And then I came across there's four fundamental forces. And today we can talk about two. So the first is the gravitational, and then the second is the electromagnetic, or you can say the electromagnetisms. This is kind of like the very big subject in physics. Yeah, and the first thing is, have you studied physics before in school?
Physics. In my memory, it seems like only got 1 year, which is the Form 3 in my secondary school. Yeah.
Yeah, 1 year is a long year, is it?
Yeah.
Then what have you learned?
Yeah, I think I returned back most of my knowledge to my teacher.
So do you think physics is important?
Physics, I think it happened in many things in our life.
No, I mean, so do you think it's important? Have you used it? Have you tried to use physics to think, to think, to kind of like to use it to make decisions, to guide you to something?
Yeah, I think to me it is not so important. The usefulness of physics to me is very limited.
Then okay, and one thing is, do you still remember anything you learned in physics? Anything.
Oh,
It could be anything.
yeah, there is one thing which is like when we sit in the car and we apply the brake and then we can feel our body keep moving forward, but the car like slowing down, so we will like hit the front.
This is something like the opposite forces, right?
Yeah.
Yeah. And yeah, because I also have learned that part in my school, okay, but
Yeah.
I don't pay attention on it. But I relearned it, or I teach myself this part few days ago, and this is something like this is a law of Newton's, is it?
Yeah, I'm sorry, I forgot already.
Yeah, I think it's a law of Newton's, and because I forget which law. Maybe it's the second law or the third law. Newton say that it's kind of I couldn't give a very full sentence, because if it's a law, the sentence must be very clear. Like something like when you when you add a force, you add a force or you increase a force at one direction, and then the force, it will also have another opposite force and push back to you. So for example, you are pushing the wall, and then the wall is kind of like pushing back to you. Yeah. And when you punch the wall, you punch it very lightly, and then the wall will paint the structure, and then the concrete will have some minor damage. Yeah. If your punch is hard enough. But most of the time our punch is not hard enough. And yeah, so our feet will get pain. And then And then if you punch it more harder, you punch really, really hard to the wall. Because the structure of the wall is very, very concrete and it's also very, very tight, or let me say high density. And then, so the wall, nothing, the wall is kind of like still the wall, nothing damaged.
Yeah.
But the force will kind of like, I'm not sure how it works, but kind of like your force will distribute to every of the nearby atoms, or maybe protons, or I don't know how to describe it. So every single particles, maybe this is a proper terms, every single particle, and then so it kind of like can distribute your forces. The forces come from your feet, so they don't get damaged. But at the same time, the opposite force is pushed back to you, and then push back to your feet. Then your feet get pain. You may break your bones. And also, and this is so fundamental, because if this is true, that means we won't have the perpetual machines. We can't build perpetual machines. And this thing, and this part is actually more attributable, or maybe we can say is major explained by another part of physics, which is the thermodynamic. Have you learned this before? Thermodynamic.
No, I think I also forgot.
So so we can't build a perpetual machines. And one thing is kind of like, and this is something related to our today topics. I miss the opposite force, not the thermodynamic. And the opposite force, what is related to our today topic? Two of the forces related to, which one do you think?
Gravitation.
Yeah, gravity. Why?
Yeah, because gravitation to me is not related to the magnet. If I just look at the two terms here literally.
But actually, of course, the electromagnetics also follow the same physics law. They can't violate the Newton's law we mentioned just now. So unlike the economics, unlike like the nutrition science, physics, chemistry, biology is something like a very, very real science. Very real science, especially physics. Of course, the assumption of the physics can be wrong. But if the assumptions based on physics is correct, and it apply in so many areas, it apply in our small Earth. It also can apply on the universe. You can assume this is the reality. So this is also, this kind of science also called the natural science. It's not called a social science. Economics, all of this is a social science. And natural science is, we can say, is important, just like the mathematics. Why mathematics is so important? 1 + 1 always equal to 2. And you can build knowledge based on it. So talk about the first video. This is the dam, right? How to harvest the hydro power. So have you learned this before? How do we harvest the dam? How do we harvest energy from them?
I think I forgot where I got the idea from. I have some rough idea how they use the force. I mean, if it is a dam and then they block the water, so the water must have like uh, a very big forces because they stop the water just like you put your finger uh, at the water tube. Yeah, and then you stop the water. They will have a force coming out.
Mm.
Yeah, just like that. So maybe it's like uh, watch some videos before, or maybe somebody told me before. But it
It
is
means
just a very rough idea.
you mean this is something like the small experiments you done in the lab, something like that, school
In
lab.
the lab, I think
How
no.
it, how it related to the real dam?
Yeah, I think it is just. I heard of how they use people use dam and then to generate electricity. Uh, yeah, I heard this before, but yeah, I think the rest of the thing maybe is like from my imagination.
Mm.
Yeah, and
Yeah.
but if you talk about there is what's that? Yeah, the water will go through one thing, but I forgot the term.
Mm.
For that thing, I have no idea. Yeah,
Yeah. So have you watched the video?
the video you shared with me,
Mm.
yes.
Mm. Yeah. And so how does the dam work?
Yeah, the dam. Okay, they built something to block the water. Maybe it's the river. Maybe you can imagine like in the
Mm.
middle of the river, they block the water from flowing to the downstream,
Mm.
and then when they block it, the water like accumulates to a high level, and at that time, yeah, there is a force because the water is like higher than uh, is getting higher and higher. So we can imagine that let's say we build a wall to stop. And so the wall must like have to bear a very big forces from the water. So we can like build something like an a hole, yeah, which we can let the water to flow to go out. Yeah, so when the water go out, and then the water must be like going out strongly,
Mm.
yeah, and then powerfully. So that water uh, can push. Yeah, yeah. Again, it's the term. I forgot the term. Yeah, can push the something, and then that thing will kind of like rotate. Yeah, and when
Mm.
it
Yeah. Yeah.
rotates,
A turbine. It's called turbine.
yeah, turbine. Yeah, so the turbine rotate, and they can like store the the power from that, just like uh,
Yeah.
the wind
Mm.
power. You
Mm.
also use the same thing, right? Turbine.
Yeah. 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 Right. And yeah, the turbine will link to the electric generator and convert the kinetic energy to the electricity. But this part we can ignore. We just focus on the first part, which
Mm.
is the water flow through the turbine and then turn the turbine.
Mm.
And we can focus just this part. And what kind of thing make this happen? What kind why? So I think my question is
Mm.
why the water, if you accumulate a lot of water,
Mm.
a very high level of water, and your turbine, can you build a turbine at upside?
Upside, you mean at the top
Mm? Yeah.
of the dam cannot? Yeah, because the water is attracted by the gravity, so it must be
Mm.
going down.
How about if you put? How about if you build in the middle?
Middle, yes, but uh, the power is not like you didn't make it the most efficient way. Yeah,
Why?
and uh,
Why not? Because like the gravity,
mm,
if you build in the middle, may wouldn't it the gravity force is kind of higher because it's higher. I mean the height is higher. You have the gravity force is higher.
Yeah, okay. Let assume that the dam, we have A, B, C. A is like at the top of the dam, the water level. B is the at the middle. C is at the bottom. If we build the turbine at the middle, so only the water from A to B, they will have the pushing power, pushing down. And from C to B, they just doesn't work, right? Because they are below the turbine.
C is at top.
C is the bottom.
Oh, yeah. Can you repeat all the things before? A
Okay.
is at the
A
top.
is at the top,
B is
B is middle, C is at the bottom. And
okay.
build the turbine at the middle means that it is near to B, right?
Mm.
Yeah, so only A to B, the water in from A to B have the pushing power.
Mm.
Yeah, B
Yeah.
to C is like wasted.
Mm. So how pushing power relates to the gravity?
If I didn't get it wrong, it is like the weight of the things itself plus the gravity. So if the weight is like uh, very heavy, then the forces plus the gravity or multiply, I don't know, the forces in turn will be greater.
Yeah, and also another thing is, can gravity change?
Gravity, gravity can change, but I think it need a very big distance, long distance.
Long distance. Do you mean
Like we are in the when we are in the moon and then the gravity is very low.
how about in the Earth?
In
Will
Earth,
the
I think
will the gravity change? For example, in the ground, the gravity is different from in the sky.
um actually I don't know. I think there must have some very little difference here.
Yeah.
Maybe like one at the deep sea, one is maybe on the very high mountain. I think there is a little, very little difference. I
How
don't know.
much little?
Uh,
10%?
I think it's like maybe 0.1%, something like that, because I haven't heard people say if they weight themselves on the mountain, they will like become lighter.
Mm.
Yeah, never
Yeah.
heard before.
Yeah. And you're right. Yeah, gravity doesn't change. I mean, at least in the Earth. Of course, if you go beyond the velocity of the Earth, I mean, go maybe it's kind of like go beyond the Earth, and the Earth, the gravity of the Earth cannot grab you anymore, and then you are going into the universe. And when you go to another planet, for example, like the moons, for example, like the maybe other orbit, and the gravity of the orbit will also like drag you.
Mm.
This is the gravity,
Yeah.
and this is in Newton's it called the gravity, and in the Einstein's this is called like the attraction, maybe something like that. Mm. In the in the in the relativity theory, it's called attraction.
Mm.
Mm. And just now you also right. If you want to think, have a greater force, have a greater force, the mass and also the velocity, which is the speed, is very important. Of course, the gravity is also important. Yeah, if you have a higher gravity, and then the force will be higher. But and but okay, but another thing is, if you just drop two things, I think you heard this before, right? You drop two things. The first is a very light, let's say like the basketball, and another is kind of like a
The
steel
iron.
ball. Yeah, the
Yeah.
iron or the steel ball, and one is very heavy, one is very light, and then you drop them from the same height. which one will fall the floor first?
Yeah, seems like the same, right?
Yeah, the same, right? So unless you push the what I say is you enforce, or maybe you add some strength on it, you increase the energy on it, and then the force will increase. Yeah, but the gravity will not change. Try to imagine you throw a basketball and also you throw an iron ball. Yeah, and try to imagine the iron ball is very, very small. Okay, maybe it's kind of like a marble, like the marble size.
Yeah.
And if you throw the marble size iron ball to people, throw to a person, and he will feel pain, right?
Yeah.
But if you throw hard enough, it may cause him die, right?
Yeah. Yep.
So this is the forces. If you increase the forces, and also the thing will move faster, right?
Yep.
Yeah, and also the force will be stronger. And if you throw a marble-sized basketball, you throw very light, people can't feel it. And if you throw very, very strong, will they feel pain? Maybe yes. But will you kill them? Impossible, right? Because it's made of rubber. And so so in order to let the forces strong enough, you need a mass. Mass is important. So why they build the turbine at the bottom? Because all the water is pushing down. The mass is pushing down at the bottom layer, the water, and push it to flow through the turbine. So the force is very the mass is very, very very heavy. So it makes the forces stronger. And also gravity act the play a very, very important role at here. Otherwise, the mass will not get spread out. And then to push through the turbines. Yeah. So this is something like we understand the world, and then we understand the gravity, and people is so smart. Yeah, we kind of like can harness the gravity to turn it into the energy. Yeah, you think it's a water is an important thing, right? But no. Yeah, actually it's not the water, it's actually the gravity. Gravity work at here. If you don't have the gravity and just the pure water, and then you cannot harvest the energy. Yeah, and also if let's say you are in the moon, the gravity is not strong enough, and then maybe the same size of the dam cannot generate enough energy. And then when energy flow, it will lose energy. This is because of the first law of the thermodynamics, the conservations of energy. So when you try to send the electricity to the consumer, to the household, it will lose some energy, and then you trace back to the origin, which is the water dam, and it must have to build bigger and bigger, maybe a few times bigger than what we have at the current age, at what we have in our planet. You have to build a very, very giant dams in order to supply the electricity to every household by using the water dams. And is it able to do that? it's very difficult, and you don't have so many water. Yeah, so it doesn't work. If the gravity is lighter enough, it doesn't work. Yeah, and we're not only using the kind of like the water to generate energy, and we are not only harvest the gravity, try to leverage the gravity to harvest the energy. We also apply it to other areas to harvest energy, maybe to let something to let something fly, yeah, or to move something. Yeah, and yeah, gravity is very, very important. And so, and also what I learned is we have kind of like energy is kind of like the potential energy plus the kinetic energy. It's kind of like I forget the formula. It's kind of like E equal to P plus U. E is energy, P is the potential energy, U is like the kinetic energy. So kinetic energy is something like the energy comes from the movement. And potential energy is kind of like potential. If you move a weight at a very high level, and then you drop it, so it will drop, right, because of the gravity.
Yep.
And then if you move the thing higher and higher and higher, the potential energy will higher and higher and higher. And also, when the thing is higher, when it drop down, it's higher, and the force will be stronger. Yeah. And also, this is constant with the Einstein's. I forget what formula. It's kind of like I forget. Yeah, E equal to mc squared. Yeah, it's not the square. It's not square. E is E equal to mc. What is it called? The power. Yeah, power 2. Yeah, E equal to mc power 2.
You mean the power root, right?
Yeah. The power root. Yeah. And the C power root is a force, something like a force, and M is a mass, and E is energy. Yeah. So go back to one of the example. If you throw a basketball, and it will cause some damage. And if you throw if you throw the iron ball, if you throw it very lightly, yeah, it will make you pain. But if you throw it very, very strong, use a very high force, you spend more energy to throw it, and then the forces is greater. It will create greater damage. Yeah. So this is kind of like the C squared. So the C squared is kind of like not C squared, C power. And C power is kind of like the relationship between the input and the output. The input is energy, and then the output is kind of like the forces it creates. Yeah, so that means if you increase the input, which means you increase the energy. You increase the energy, for example, double the energy from 1 to 2.
Yep.
And then you throw the ball, and the forces will be power 2. Yeah, so this is kind of like a bigger, create a bigger amount. So yeah, and So yeah, just now you are right. The mass and also the height is important, and because we can kind of like the more cleverly to utilize the gravity, this one of the most fundamental forces, and to to increase the force, and then push the water through the turbines. Yeah. So does all of this thing remind something you learned in physics?
Yeah, I still couldn't. But one thing comes to my mind is the friction. Yeah, but it is not very related to today's one topic, right?
Yeah, friction is the opposite, is also the opposite forces, right?
Yeah.
And go to the next one, electromagnetic. So you also have watched the video, right?
Yeah.
So yeah, what's the feeling after watching it?
Okay, I would like to say that it seems like many of the electric appliance that we use in daily life is using this concept, is it? For example, fan, which is mentioned in the video, and the hair dryer, that kind of things, which will they will like spin very fast, and then the all of the I'm not sure whether all of the home appliance which they will have the spinning is because of this concept. But it seems like most of them is this concept, right?
Yeah, it converts one form of energy into another form of energy. For example, it could be just a mechanical energy. For example, have you played one type of toy car, and it's kind of like there's no battery, and then how to make it move? It's kind of like you have to move it backward first.
Yeah. Yes.
And then you release, and it will go more. It will go more than you push backwards. Is it?
Yeah. Yeah.
Yeah. So it's kind of like, it's also kind of like when you move backwards, and then you kind of like increase the potential energy. Yeah. It's kind of like you hold an arrow, and then you shrink it, and then when you release it, the arrow will kind of like will fly. So when you kind of like you pull the arrow, and then you kind of like create a potential energy. Yeah.
Yeah.
And then
and also for clock, right? Not right now, maybe like few decades ago, our clock, our watch, they also use this mechanical concept, is it?
Yeah, they also kind of like use this concept. But this is not the perpetual machines, right? You need to kind of like keep spinning. I remember I remember when I was in secondary school, and one of my classmates, he bought this kind of clock, and everyone was amazed because don't need to put battery, and they just need to keep spinning, and it can last maybe few hours or few days. I'm not sure. And when he got free time, he just keeps spinning. And in order to prevent the clock stop working. Yeah. Yeah, it's the same using the same mechanism to let something work.
Yeah.
But it also converts one of the energy to another energy. Yeah, in this case, you can kind of like imagine convert your chemical energy, right? You eat the food, and then you have the energy, and then when you do something, it consumes your energy.
Yeah.
If you keep sitting at the chair, you keep spinning, you release the energy, and then you need the foods. You need more additional food. Of course, the additional foods is very, very little. But try to imagine you want to spin a very big clock, very big, in order to make the maybe something like, for example, in some cities there's some big clock, right? Everyone can see. It's kind of like a building, and there's a big clock. Try to imagine you are the worker, and the clock is a is kind of mechanic, and then the maybe the government or maybe some organization who built the clock, to build this mechanic clock, and then they need to hire one person to keep spinning the clock, right?
Yeah.
So the clock is so big, and then you need some energy, and it requires big energy, and then the worker who keeps spinning the clock to keep it run. And yeah, so it make you hungry. It make the worker hungry faster. So you need to eat more food, and you are tired. You need to rest, something like that.
Yeah.
So it's kind of like you make it larger. You make it larger, and then you can see the difference, the nuances.
Yeah.
Yeah. So it's kind of like convert the chemical energy into the mechanic energy, or convert it into the kinetic energy. You raise the potential energy, and then when you release the potential energy, convert into the kinetic energy. You can also say you use your chemical energy, turns it into the kinetic energy because you move your hand. It's kinetic, and then kinetic energy you convert into the potential energy, and then you release. So the potential energy decreasing, and then the kinetic energy on the clock increasing. And so it creates the mechanic energy. So mechanic energy also has a formula. Mechanical energy is kind of like equal to it. I think I mentioned just now already. The mechanical energy is equal to the potential energy plus the U plus the kinetic energy. Yeah. Yeah. So yeah. Is there anything for the second video?
Yeah. Second video is about electromagnetic, right? Yeah. Yeah. I think this one, I actually really don't know how they function before watching this video. So right now I feel like actually they are like the law is so great, because after so many years you can see our technology keep advancing, and we have more and more things to use. Yeah, for example, those home appliance like vacuum or what, they still like use the same the same law, right? They use the same way to generate the energy to make them move.
Yeah. So this is physics. Physics so important.
Yep.
A lot of physics, a lot of nature, and also people is so clever, right? And it's kind of like the video is kind of like from the very, very beginning, from the very just a pneumatic, and then it kind of like the force is the same, and then this is still the electromagnetic, and then they build something layer on layer on layer, and the whole thing become more complicated, but make it automatic, right?
Yeah.
Yeah. And this is a very the electromagnetism is kind of like one of the very important field in physics, and I haven't figured out, and I also didn't spend much time in it, compared to other part. Yeah, so I have nothing much to say about it. But it make me realize that, wow, how our world actually work, right? What's the nature? And also, all of these things we think is normal, we think is unimportant. For example, gravity. For example, the matic. It's kind of, I think it's just like the play tools.
Yeah.
But actually, because of the mechanism, because of the law, it creates so many things.
Yeah.
And it also reminds me something that I actually have studied physics in the past, but very, very short period, and I don't have much interest on it. And one thing I remember, my physics school teacher said that physics is something like you don't know what it is, but you still have to learn it. And I very, very hate this statement, very, very hate this sentence, because why we don't know it, we still need to learn it. Why we don't know how to use it, something like that, we still need to use it. We still need to learn it. But maybe there's a second half part. I didn't maybe there's a second half part, and then the second half part didn't come into my mind. Maybe I forget already, or maybe I just listened the first half part. Yeah, because the first half part is, okay, I don't I don't know whether there's a second half part, because this is something like I didn't pay attention.
Yeah.
And then after some days, and my classmate, my friends told me that our physics teacher actually said this in the past. Yeah, so I don't know. Maybe the second half part, which is talk about how the physics regulate of our world, how the physics act as the law of nature, govern everything in the universe. Yeah, and also at that time I don't know why physics is important, but now I know. The more I learned, the more I understand how important physics is.
Yeah. Yeah, but at the beginning of the topic, you asked me whether physics is important, right, to me. To be honest, right now, I know that it explains many of the things that happen. But when we say application, to me, I still don't know whether if I know a lot and know a little, will I still don't find how it will affect me, actually.
Use it as a mental model. Use it as a thinking tools. Improve your critical thinking. Try to imagine. Okay, let's say the toys car example.
Yes.
You move backwards, and then it will go beyond. It will go beyond the space, the distance you move backwards, right?
Yeah.
So how would they apply in our real life? Prepare and wait. You accumulate the potential energy. When the time is coming, when the time is mature, when the opportunity comes to you, you can move forward. You can move very, very fast. You can move very, very longer. You can move very, very farther. You get what I mean?
Yeah, it's like analogy, is it?
Yeah, and this is not just an analogy. It's just not the analogy. This is the law. This is the law of physics. And you think law of physics just control all the non-living things? No, it also control our living. It also control human, every animal, and all the all the living things. It's just doing. It's just not obvious, you know. But if you zoom out and you see, it actually is the same thing. Even though you look at some history, you can see actually the physics applies in so many areas. Yeah, apply in the social economics. For example, revolutions, social revolution, how it occurs, how it formed. Don't you need something like accumulation? And when the accumulation big enough, and it can change the whole thing.
Yep.
Something like gradually, then suddenly, right? Have you seen any of the social evolution is kind of like slowly change everything? Have you seen kind of like the war, maybe the civil war, kind of like the reason to make the war, the reason to declare the war don't require any accumulation, don't require any accumulation of the potential energy. Just like, okay, I want to fight with the person. This is a person I have no idea with, of this country I don't have any idea, and I want to fight with them. Or maybe two countries doing some trade. It's doing very, very well, and one day one of the country, the king of the country, wake up, yeah, I'm feeling unwell, I want to kill the king of another country because he must feel very well. I also want let them feel unwell. So no, yeah, there's some accumulation of the anger, accumulation of the negative emotion, and then this is the accumulation of the potential energy, and it turns out declare the war become a kinetic energy. Yeah, human fight with human. This is the kinetic energy.
Yep.
Yeah, it could be many things. For example, friction. You do something, you have friction, right? So you need to make something work. You need to spend more energy to fight with the friction. In overcome the friction, so you can get some results.
Yeah.
Otherwise, your result will just be net off, or maybe it's not your result. It's your effort will just be net off and then create zero result. So you need to work harder. You need to fight against the friction. And another way is you try to reduce the friction. We learn in the habits. We learn in the atomic habits.
Yep.
Right? Reduce the frictions. Now, it's a real thing. This is not just borrow the analogy from physics. No, it's a real thing. Try to imagine every of us is just a bunch of the energy. Bunch of the is like the bunch of the membranes, bunch of the substance that can group the energy, then can store the energy, collect and mix the energy and store inside your body.
Yeah.
You actually just bunch of energy, right? The energy convert into another form of energy. Try to imagine you give birth a child. Where the child come from?
Yeah.
You give birth a baby. Where the baby come from?
From the sperm and the egg.
Where the sperm and the egg come from?
Yeah, from our body, which we consume foods, and then the nutrition.
Allocate to our cell and some organs, some sexual organ, and build and then to produce the egg, to produce the sperm, right? And how this organ forms. And this is from his mother body, and it's kind of like recursion. And if you don't have the foods, can you have life? Can you give a baby? You don't consume more foods. You don't have the nutrition. In another word, you don't have the energy to move some of your to make your sexual organs, to inform your body, to create new life. Create new life require energy. And how about if we don't have sun? If we don't have sun, plant die, animal die, human die. Then we don't have life. Sun is energy. Yeah, sun is the most important energy for the earth. Sun create life. Sun create reality. No sun, no life. Yeah. And you say, yeah, I can build an artificial sun, but how do you harvest the energy of this thing? This also come from the energy. Yeah. So this is not just an analogy. Physics really regulate, really control many things in our life. Yeah. Even though it's something like kind of like, but one thing we should know that you need to look long term, and you need to look in probabilities. Physics control the movement, control how the non-living thing live, how the non-living thing functions, but it should not fully control, fully regulate how living thing work, especially human, because we can think, we can act. But if you zoom out and see, and also if you think in probability, how it's likely. Yeah. In 10 times, how many times we end up restricted by physics? Yeah. For the social science part. Yeah. So you kind of like introduce a natural science into the social science, and you found that most of the time natural science work. Yeah, it doesn't work 100%. Most of the time it work. And also, for example, like the Einstein relativity theory, the attraction, you can explain in the interpersonal relationship. Some people put more effort, convert their energy into something that can increase their attractions. And if you look from this length, you won't say they're doing something stupid, they're doing something non-productive. No, they are smart. They know how to create their own gravity, their own attraction. And then they can attract people comes to them. And maybe they can harvest the energy from them because he or her himself have the gravity, can harvest. When the people is more richer, which means greater mass, right? Heavier, and maybe farther, and and when the attract comes to him, the forces is greater, which means maybe the benefits better, benefit greater. It can be explained through the physics, through the Einstein relativity theory. E equal to mc power 2.
Can we think like the wealth is kind of like the energy store because it can make other things move? For example, they can hire many people to work for him. They can buy maybe they can buy some machine, then make the things work.
Yeah, and it's a physics, For example, in the past, how people transport the thing. They use their own hand at the very, very ancient age. And then after sometimes they build the wheel. They put something on the wheel and then they can push, right? They can put a lot of weight. And I'm not sure whether it's Histopotamia, something like it's kind of like I think I pronounced it wrongly. It's kind of like Mesopotamia, and in that kind of ancient age, and then how they build the pyramid. How they build the pyramid? They use this kind of tools, and they can move tons of the rock. The tons of the weight of the rock in that age. Yeah. And you try to ask a modern people, how do you move a tons of the rock from one place to another place? Tons. Yeah.
Tons. You need trucks or trains.
But what if you don't have trucks, you don't have trains? Yeah. In the ancient age, they figure how to use it, how to use a physics to convert the energy. Yeah. To kind of like try to reduce
friction, right?
Reduce friction and also reduce the losing of the energy. Yeah, and also like in our current modern age, we have the electricity flow through the grid, right? And when technology advances, we try to improve the efficiency. We try to reduce what's it called, reduce the waste. Okay, because when you move the energy, you will waste some of the percentage. They try to increase the efficiency. For example, initially solar energy, maybe you can only harvest maybe 10% or 5% of the energy come from the solar panel. The sunlight received from from the solar panel. And after some time, the advance they figure out, and then they increase the efficiency maybe from 5% to 10%, from 10% to 15% to 20% to 30%, increasing the efficiency and harvest the energy more effective, more efficiently. Yeah, and this is also what human do, not only in energy, in every other area. The car, we build a car, build a train, even though we build a pencil. Yeah. In the past, how do you write something? How do you record something? You cave you cave it. Yeah. And the printing press, and also like the soft copy the document, the computer, all these things. Yeah, and humans, you can say human is a creature that know how to harvest energy, how to channel energy in a more effective way, in a more efficient and effective way, unlike other animals. Unlike other animals. Try to imagine, what if other animals, they know how to store the food into a freezer. They know how to cook the food. Then they have a lot of free time to do something else. They can improve. They can have their own civilization. But no, other animal is kind of like hard coded inside their brain, which is they will just function one thing very, very good. But they have no thinking. They don't have their own thinking. And some of the animals, they have they still can think. They still can feel something. Maybe like one of the video I saw, I have watched, is kind of like the monkey. I'm not sure it's a monkey or gorilla, or maybe the chimpanzees.
Yeah.
They can feel unfair. So they have the sense. They can feel unfair. Yeah. For example, you give one of the chimpanzee the grape, and you give another chimpanzee maybe I don't know, maybe meat, maybe some other thing. Yeah. And for example, the chimpanzee, they prefer, let's say they prefer meat.
Yeah.
They prefer meat, and then they'll feel unfair. And for the chimpanzee who only receive the grape, they'll feel unfair.
Yeah.
Yeah. Yeah. So yeah. So this all the thing I want to share for today's topic.
Yeah. It gives me a feeling again like mathematics. At the beginning also, I think mathematics is something. It's a subject in the school, and then after that, after we graduate, mathematics seems like not important. The same feeling again for physics.
Not important.
No, it depends on how you use it. And for example, just now you explained like how the physics can be applied in our life, not only like the non-living things. If it is applied in, let's say, the humans interactions, something like that.
And also, if you understand all of these things, you have the idea, you have the concept in your mind, it can avoid you to do stupid thing,
Yeah.
And when you try to build something, when you try to turn an idea into a reality, you will see, you'll try to figure out whether it is violate the physics law, whether it violate the mathematics law. If it is, don't do it. You are going to fail. You're certainly going to fail, because
For
you violate
example,
the physics.
gambling,
For example,
gambling, right? Mathematics.
Gambling, mathematics. Yeah. So can you think any other thing that violate the physics law?
Okay, driving very fast, out of control.
It could be. Yeah. The friction can hold you.
Yeah.
Yeah.
Yeah, or maybe putting a lot of effort and energy and time in something that is not aligned with your goal.
Yeah, it's a very good example. Because you kind of like didn't channel the energy efficiently and effectively. You consume so much energy, you take so much input, but you create so little output.
Yeah.
And it is one of the things in physics, which is a velocity. Velocity is the speed times, or maybe the speed and also the direction. Speed is just a speed. You can move very, very fast, but you don't have any direction. You comes to the origin.
Yeah.
And you just kind of like keep moving in your rooms. Yeah, you're moving very fast in your room, but you go nowhere. Or maybe you are like the race. You're like the mice and running on the wheel. Keep running so fast. The wheel, it's a good turbine. It can create a good turbine, but you go nowhere. So you must have the velocity. You must need to know direction, and direction is more important than speed. The direction is more important than speed. You need to focus on velocity. You shouldn't focus on speed. When you try to do something, you need to figure out why something they want to achieve. What is the purpose of doing this thing? Know why. Using physics to explain why. Knowing why is so important. Is it consistent with physics law? You understand why you should do this, and then so that you got the direction, and then you can move slow, but you have the progress. Unlike other people, they don't have direction. They move so fast, but they don't have any progress. This is physics. So know why. Know what physics. Knowing what you want is physics. It could be philosophy, but it also could be physics. You see how important it is.
And one last question to you. If you can travel back in time when you were in the secondary school, when you were sitting in a class, a physics class, will you like pay attention to the class?
If I know why, I will pay attention. But at that time, I don't know why. I don't know why I should learn physics. And also, one of the example is how a teacher channel energy more effectively and more efficiently. Teach the student know why. Right? Teach the student critical thinking. Teach the student problem solving. And then they become a better student that don't require you to teach, but they want to stick with you. They still want to stick with you because they try to learn every single knowledge, every single wisdom from you. They will tell their parents, I only want to learn with this teacher. I don't want any other teacher. And as a teacher, you channel energy more effectively, more efficiently. You also create your own attractions. You create your own age. You create your own gravity. And other people who just spend their time accumulate the hard skill, they can't fight with you. You provide something beyond them. They just can't do it. So this is physics. Okay, so anything you want to add in?
One last sentence. I think starting from today, physics to me is not just a lot of formula, a lot of words. But it is actually quite interesting.
And also you'll find kind of like memorizing a formula is more easier, or understand because you understand it. You're not trying to memorize it.
And maybe you find the meaning of the meaningfulness, right?
And you learn the formula is not because you want to do some mental gymnasium, which is the examination. The paper, the exam give you some constant variable, and then you just plug into formula, and then you can get the answer. No, in reality, you don't have a constant variable. Maybe it has, but you need to find out by yourself.
Mm.
You need to find out the variable by yourself and do your own calculation.
Yeah.
And also there's no right and wrong because you need to think in probability. The variable is not fixed.
Mm. Yep. Okay. Yeah, that's all what I want to say today.
Okay, talk to you tomorrow.
Yeah, talk to you tomorrow. Goodbye.
Goodbye.